to 30. 75 tons of fury and the most powerful gun in the history of United States heavy tanks. The summer of 1944 turned into a real nightmare for American tankers who landed on the coast of Normandy. The crews of Sherman medium tanks, which until recently had successfully smashed the Italians and Germans in North Africa, suddenly encountered an enemy against whom their machines were practically powerless. From dense French groves and from behind the stone walls of Norman villages, German Tiger heavy tanks and the newest King Tigers, whose frontal armor reached 150 millimeters, opened fire on American columns. The 76-millimeter shells of the Shermans bounced off these steel monsters like peas off a wall, and in response came 88-millimeter rounds that pierced the American machines through and through. In just a few weeks of fighting in the picturesque Norman fields, hundreds of Shermans remained burning, and the United States Command finally realized the scale of the catastrophe. The problem was that American generals had rested on the laurels of North African victories for too long. Successes in Tunisia and Sicily convinced them that medium tanks were doing their job just fine, and heavy machines represented only an expensive and clumsy burden for advancing armies. The M6 heavy tank program, developed at the beginning of the war, was effectively frozen after these bulky machines performed extremely poorly in trials. Weighing nearly 60 tons, the M6 possessed weak armament for its class and suffered from constant transmission breakdowns. Therefore, the command gave up on heavy tanks and concentrated on the mass production of Shermans. This mistake cost the lives of thousands of American tankers in the summer months of '44. Panic gripped the American military leadership at the end of July, when it finally became clear that existing equipment was unable to stand on equal terms against German heavy tanks. Urgent meetings followed one after another. Generals demanded immediate solutions, and designers feverishly searched for ways to somehow fix the situation. The first idea was a deep modernization of the ill-fated M6, designated as 6A2E1. It was proposed to install a new turret with a powerful 105-millimeter gun on the old chassis. However, General Lucius Clay strongly opposed this project. He rightly pointed out that the modernized machine would weigh about 77 tons, while retaining all the flaws of the original design, including terrible mobility and an unreliable chassis. On August 14, 1944, at another meeting, the proposal to create a completely new heavy tank, designated T29, was voiced for the first time. This machine was to combine a chassis inspired by the design of the promising T26 with the turret and armament from the M6AE1. The 105mm T5E1 gun could theoretically hit German Tigers at decent distances. However, some specialists immediately had serious doubts. The main opponent of the future tank was to be the King Tiger with its 150mm frontal plate, and by no means everyone believed that the 105mm gun could guaranteed pierce such protection. It was at this moment that a project was born that was destined to become the most powerful tank in the history of American tank building of that period. On the same day, August 14th, a decision was made for the parallel development of another machine under the index T30. The hull and turret of this tank were to be identical to the T29. However, the armament was planned at a completely different level. Instead of a 105mm gun, designers proposed installing a gun with a caliber of 155mm, created on the basis of the famous long-range howitzer known by the nickname Long Tom. This was a real monster, whose shell weighed 43 kilograms and could turn any enemy tank into flaming wreckage, regardless of its armor thickness. Officially, work on the T30 started on September 14, 1944. Initially, it was planned to build only 2 experimental prototypes, as the command viewed this machine more as a backup option and a testing platform for a super-powerful gun. Unlike the T29, which they planned to launch into serial production in a volume of 1,000 units, the T30 was never intended for mass production. However, the engineers who received the task of developing this steel giant could not have imagined the technical problems they would have to overcome and how much time the creation of the most powerful American tank of that era would take. The gun that was supposed to turn the T-30 into the deadliest tank of its time had a rich combat history even before it was adapted for installation in a turret. The M1A1 howitzer, which received the nickname Long Tom among artillerymen, was developed in the late 30s to replace the obsolete 155mm M1918 gun, which was a copy of a French weapon. The new howitzer possessed outstanding characteristics, and in its capabilities approached the Soviet 152mm high-power gun BR-2. The muzzle velocity of the American gun was slightly lower, and the shell itself was a bit lighter. However, overall, both systems demonstrated comparable effectiveness. At the same time, the Soviet Union produced only 39 BR-2 guns, while American industry from October 1940 to June 1945 produced 1,882 Long Toms. Practically no major operation in North Africa and Europe took place without the participation of these powerful artillery systems. To be installed on a tank, the gun had to be seriously redesigned. The barrel was shortened to 6,414 millimeters, which was 41.4 calibers. The muzzle velocity of the shell decreased to 717 meters per second. However, even in this form, it was the most powerful tank gun ever created in the United States at that time. The new gun received the index T7 and could use several types of ammunition. The ammunition load included T35E1 armor-piercing shells with a high-speed core, M112B1, and T291 armor-piercing heat shells with a protective cap, M107 high-explosive fragmentation shells, and M110 smoke shells. Any of these shells could send an enemy tank to oblivion, whether it was a Tiger, a Panther, or even the most powerful King Tiger. However, this gun had a significant drawback related to the size of the ammunition. Each shell weighed 43 kilograms, and the powder charge added another 18 kilograms, so the full weight of the round reached 61 kilograms. No single person could alone lift and load such ammunition in the cramped space of a tank turret. Therefore, designers had to provide for 2 loaders in the crew at once. One of them operated a special lifting mechanism that extracted the shell from the ammunition rack and fed it to the breech of the gun, and the second activated a spring-loaded rammer that pushed the ammunition into the chamber. Even with the coordinated work of both loaders, the rate of fire did not exceed 2 rounds per minute with manual loading, which was extremely low for a tank battle. The dimensions of the gun and ammunition required the creation of a completely new turret with a high, rounded profile. Only such a design allowed for the placement of 2 loaders inside, who had to work standing at their full height. Moreover, loading was possible only at certain elevation angles of the barrel, which imposed additional restrictions on conducting battle. The frontal armor of the turret reached from 203 to 305 millimeters, depending on the section. The side armor was 158 millimeters, and the rear was 102 millimeters. Such protection made the T-30 practically invulnerable to most enemy anti-tank weapons during a frontal attack. The hull of the tank was protected no less impressively. The upper frontal plate had a thickness of 102 millimeters and was positioned at a rational angle of inclination, which significantly increased its shell resistance. The sides of the hull were covered by 76mm armor, and the rear by 51mm armor. All this magnificence, combined with a massive turret, a heavy gun, and an ammunition load of 32 shells, pushed the weight of the machine to 75,800 kilograms. For comparison, the T-29 tank with a 105mm gun weighed 64,183 kilograms, that is, almost 12 tons less. The difference in weight was explained not only by the heavier gun, but also by the increased ammunition load of the T-29. which carried 63 shells compared to 32 in the T30. In addition to the main caliber, the tank was armed with 2 machine guns. A coaxial heavy-caliber Browning M2 caliber 12.7 millimeters was intended for engaging light armored vehicles and enemy manpower. A hull-mounted Browning M19A4 caliber 7.62 millimeters installed in the front plate of the hull served for self-defense against infantry at close ranges. The crew of the machine consisted of 6 people: a commander, a gunner, 2 loaders, a driver mechanic, and a radio operator gunner who operated the hull machine gun. Creating a tank weighing almost 76 tons set a very serious task before the engineers. Where to get an engine capable of moving this steel mountain and providing it with acceptable mobility on the battlefield? Initially, it was planned to use a 27-liter gasoline engine Ford GAZ, developing 770 horsepower. This same motor was intended for the T29 tank, and the unification of power units seemed like a sensible decision from the point of view of simplifying production and supplying spare parts. However, the first calculations already showed that the specific power turned out to be depressingly low. For a machine weighing 75 tons, 770 horsepower meant slightly more than 10 horsepower per ton of weight, and this threatened to turn the tank into a clumsy tortoise, unable to keep up even with infantry. By the end of 1944, the situation with the heavy tank program had changed radically. It became obvious that neither the T-29 nor the T-30 would have time to take part in the war against Germany. Allied forces were confidently advancing toward the borders of the Reich. And although German heavy tanks still represented a serious threat, the overall course of combat operations was turning in favor of the anti-Hitler coalition. Order volumes for new heavy machines were reduced. However, no one intended to completely shut down the program. Instead, designers were given the opportunity not to rush and to refine the projects, eliminating identified shortcomings. It was then that the decision was made to replace the power unit. Instead of the Ford GAZ, they decided to install a 29-liter air-cooled Continental AV1790 engine on the tank, which could develop up to 810 horsepower. An increase of 40 horsepower may seem insignificant. However, the new motor possessed a number of important advantages. Air cooling made it less vulnerable to combat damage, since there was no complex system of pipes and radiators that could easily be pierced by a fragment or bullet. In addition, the Continental engine was distinguished by greater reliability and maintainability, which was critically important for such a heavy and complex machine. The specific power of the T30 with the new engine was 10.68 horsepower per ton, which was practically identical to the indicator of the T29E3 tank with its 10.74 horsepower per ton. Simultaneously with the engine, the transmission was also replaced. After long trials and comparisons, the choice fell on the automatic gearbox CD851, which provided smooth gear shifting and reduced the load on the driver mechanic. Controlling a 76-ton machine required enormous physical effort from the driver, and any relief of his work directly influenced the combat capability of the tank as a whole. The turret also underwent serious redesign. Initially, it was planned to install a turret on the T-30 that had been developed for the modernized M6AE1, which was called the T-29 type turret. However, during trials and modeling, serious problems with protection were revealed. It turned out that bullets and small fragments could penetrate into the turret through viewing slits and technological openings, which created a mortal danger for the crew. Designers set about the redesign, and as a result, the turret changed so significantly that only the general concept remained from the original project. Nevertheless, the turrets of the T-29 and T-30 tanks remained unified, differing only in the number of coaxial machine guns and the gun mount, which received the index T124. While engineers labored over perfecting the design, in the spring of 1945, the last battles in Europe died down. On May 8th, Germany signed the Act of Unconditional Surrender, and the war on the Western Front ended. The main enemy against whom the T-30 was created ceased to exist. However, fierce battles with Japan continued in the Pacific Ocean. The American command was seriously preparing for an invasion of the Japanese islands, and heavy tanks with the most powerful armament could be useful for storming fortified enemy positions. The first prototype of the T-30 was completed in March 1945 and received the U.S. registration number 31,628,420. At the end of March, the machine was sent to the Aberdeen Proving Ground for comprehensive tests. But in August 1945, the atomic bombings of Hiroshima and Nagasaki put an end to the Second World War. Japan surrendered, and the need for heavy tanks for assault operations disappeared. Despite this, the T-30 program was not closed, as the machine represented great interest as a testing platform for working out new technical solutions. Contrary to the common misconception that only 2 T-30 prototypes were built, documents testify to something completely different. By May 1947, 6 machines had already appeared with registration numbers from US 30,162,842 to US 30,162,847. Each of these steel giants received its own fate and made its contribution to the development of American tank building. On all machines, they installed an improved Continental A1795A engine, developed in parallel with the tank itself and distinguished by increased reliability compared to the base version. 5 of the 6 prototypes went to the Aberdeen Proving Ground, which became the main site for testing American armored vehicles. Tank number 3 remained at the Detroit Arsenal, where it was turned into a stationary testing laboratory for working out various technical solutions. This machine never left the factory walls and was used exclusively for bench testing of individual units and assemblies. The other 5 tanks awaited a much more dynamic life, filled with thousands of kilometers of travel on a wide variety of roads and off-road. However, not all machines stayed long at the Aberdeen Proving Ground. On June 8, 1948, Tank number 5 was loaded onto a railway platform and sent to Fort Knox, the famous storage of the American Gold Reserve, where a large military proving ground was also located. On July 23rd of the same year, Tank number 6 departed in the opposite direction to a testing base in Yuma, Arizona, where the machine was to be tested in conditions of extreme heat and desert terrain. And on January 20th, 1949, Tank number 4 crossed the border of the United States and headed to the Canadian Fort Churchill for conducting winter trials in conditions of Arctic cold. Before being sent to Canada, Tank number 4 underwent a break-in at the Aberdeen Proving Ground, racking up 213 kilometers on the odometer. Already at this stage, mechanics discovered defects in the transmission that had to be eliminated before the further journey. The Canadian frosts were to become a severe exam for all systems of the machine, especially for the air-cooled engine, whose operation at temperatures below -30 degrees caused justified concerns. The results of the winter trials showed that the Continental AV 1979 handled the Arctic cold significantly better than the competing Ford G installed on the T-29 tanks. Tank number 6, sent to scorching Yuma, also required the attention of mechanics even before the start of the desert tests. Some engine components had to be replaced before the machine could proceed to the trials. Additional tests took place from October to December 1948, and according to their results, the transmission had to be completely replaced. In 1949, an improved gearbox CD853 was installed on this tank, which performed significantly more reliably than its predecessor. The real record holders among the prototypes were tanks number 1 and number 2, which remained at the Aberdeen Proving Ground and underwent the most intensive trial program. The first machine racked up 800 kilometers of travel, of which 142.5 kilometers were for tests with the CD852 transmission. But the absolute record among all American experimental heavy tanks was set by tank number 2. This machine traveled a total of 3,076 kilometers, of which 1,492 kilometers were covered with the CD-852 transmission. During the trials, the engine and transmission had to be replaced multiple times. However, the overall picture was in favor of the Continental Power Unit, which demonstrated much greater reliability compared to the Ford GAZ. The results of many months of testing allowed for a definitive conclusion. The air-cooled Continental A1790 engine surpassed its competitor in all key parameters. It turned out to be more powerful, more reliable, and easier to maintain. Most importantly, it worked equally well both in the Arctic cold of Canada and in the scorching heat of the Arizona desert. This victory in comparative trials determined the future of American tank building for decades ahead. Already in 1949, the production of the M46 medium tank began, on which they installed the Continental AV1795A engine and the CD-853 transmission, worked out on the heavy prototypes. This same combination migrated to the T-43 heavy tank, which later turned into the famous M103, which became the core of the United States heavy tank forces during the Cold War years. The main problem of the T-30 tank remained the low rate of fire of the gun, and the designers perfectly understood that 2 rounds per minute were completely insufficient for modern tank combat. The work of 2 loaders in the cramped space of the turret with very heavy shells and charges was incredibly exhausting, and in real combat conditions, crew fatigue could reduce the already low rate of fire to a critical level. The solution to this problem was a modification under the Index T30E1, on which they installed a semi-automatic loading system that significantly lightened the labor of the crew. The principle of operation of the new system was as follows. The mechanism automatically brought the breech of the gun into the loading position. Then the rammer pushed the shell and charge from a special tray into the chamber, after which the gun returned to the initial elevation angle. The loaders only had to extract the ammunition from the rack and place it on the tray, while all the heavy physical work was performed by the mechanisms. In addition, an extra hatch appeared in the rear part of the turret, intended for the automatic ejection of spent shell casings outside. Massive brass cylinders weighing several kilograms flew out of the turret after a shot, freeing space for the crew's work and sparing the tankers the need to manually get rid of accumulating casings. Parallel to the T30E1, there was another modification under the designation T30E2. However, details about this version are extremely scarce and practically did not survive in historical documents. Of much greater interest is the T57 project, which became the most radical attempt to solve the rate of fire problem of the 155mm gun. On this machine, designers used an oscillating turret with an autoloader, which was a very unusual solution for American tank building. The oscillating turret consisted of 2 parts, the lower part, which rotated on the turret ring, and the upper part, in which the gun was fixed, and which could tilt in the vertical plane. Such a design allowed for the placement of an autoloader in the rear bustle of the turret and a significant increase in the rate of fire. Interestingly, autoloaders subsequently became a hallmark of the Soviet school of tank building, while the Americans for many decades preferred to keep a human loader in the crew. It was believed that a person is more reliable than a mechanism and is capable of clearing a jam or other malfunction in combat conditions, whereas the failure of an autoloader completely deprives the tank of the ability to conduct fire. The T57 project remained experimental. However, the idea of the oscillating turret itself was implemented on the French AMX-13 tanks, which were produced by the thousands and served in the armies of many countries of the world. 2 T30 prototypes did not end their career as test machines, but served as the basis for creating a new tank. They were converted into prototypes of the T-34 heavy tank, armed with a 120mm gun. This gun occupied an intermediate position between the 105mm gun of the T29 and the 155mm monster of the T30 itself. The 120mm shell was powerful enough to defeat any armored vehicles of a likely enemy, but at the same time significantly lighter and more compact, which allowed for an increase in the ammunition load and rate of fire. In fact, the T-34 became the progenitor of the gun that was subsequently installed on the serial M103 heavy tank, which became a symbol of American tank power in the Cold War era. The American wartime heavy tank program was officially closed without producing serial machines. Neither the T-29 nor the T-30 nor their numerous modifications went into mass production. There were several reasons for this. Firstly, the war ended sooner than the tanks reached combat readiness. Secondly, the enormous weight of the machines created unsolvable logistical problems. The bridges and roads of Europe were simply not designed for such loads. Thirdly, railway transportation required special platforms and took too much time. Even the maximum speed on a highway did not exceed 35 kilometers per hour. And on cross-country terrain, these giants barely crawled, unable to keep up with lighter and more maneuverable machines. Nevertheless, the 6 built T-30 prototypes rendered a great service to American tank building. 4 of them have survived to our day and are preserved in various museums and memorial sites. Tank number 1 remained at the Aberdeen Proving Ground. Tank number 3 never left the Detroit Arsenal. Tank number 5 can be seen in the United States Army collection of armored vehicles. And tank number 6 stands at Fort Jackson. These steel giants with the most powerful guns of their time have frozen on pedestals as monuments to the engineering genius and ambitions of an era when designers believed that the larger the tank and the more powerful its gun, the closer the victory on the battlefield.